You have a review for your quiz right here, so take a few minutes to work through these, and then after you're done working through it, the substitute will play the video to show the solution so you can double check your answers, and then you will have a quiz for a little bit, okay? So please pause the video, have the students work through these 4 examples. All right, working through these, first one, synthetic substitution. Remember we had synthetic and direct substitution. Direct was where you just kind of plugged it in and used your calculator to get an answer or use your brain, okay? Synthetic substitution, it needs to look like synthetic division, okay? So whatever number is inside your parentheses, in this case it's a 2, that's what's going in our box off to the left, okay? And then to set up synthetic substitution or division, we need to make sure that we have all of the terms that we need. And if we're looking at that, we have a 4th power down to a 2nd power. So that means we got to have a 0r cubed. You got to have a cube in there to be a placeholder. So we got 3, 0, 7, negative 12, and 23. If you forgot that placeholder, then the rest of the problem is going to kind of be botched here. So drop the 3 down, and then take times a 2. So 3 times 2 is 6. That's where that 6 goes. And then you just add and follow the same process all the way down. So 6 plus 0 is 6. 6 times 2 is 12. 12 plus 7 is 19. 19 times 2 is 38. 38 plus a negative 12, that gives me a 26. 26 times 2 is 52. Add those together and we're going to get 75. So the thing that we're looking for here is the remainder. The remainder is our answer when we're thinking of synthetic substitution here. So 75. And if you wanted to double check that, you can plug it in with your calculator and see that you get 75. Okay? So the next one here, a little bit more difficult factoring. We've had some of these problems on the homework. You want to look to see what you can take out first. Okay? So my guess is that we could probably take out an 8. Okay, if we can't take out an 8, then you would start with a 2. Well, let's see if 216 divided by an 8. It does. So take an 8 out, and we want to take an x squared out. Okay, so 8x squared comes out, and then we're going to have an 8x cubed at the front, and a minus 27y cubed at the back. All right? You should recognize the 8 and the 27, and then the cubes there, so that's a cubes pattern. So what we have to do is figure out what's being cubed here. We have to figure out our A and our B to apply the pattern, okay? So for this one here, let's kind of draw an arrow to divert your attention there. That's 2x. And then for this one here, that's going to be a 3y. All right, that's just kind of using the first step of the pattern. We got to figure out what's being cubed. Okay, so we got a 2x minus 3y. Let's see, yeah, that's all connected. Okay, so that's step 1. We got to figure out what goes in our small parentheses. Step 2 is now applying the pattern. Okay, so small parentheses, and then we got our big one where there's 3 things in there. It's a trinomial. So the 2x, I bring it to the front and I square it, so it becomes 4x squared. The 3y, I bring it to the back and I square it, so that becomes 9y squared. And then the middle here, okay, right there, that's a combination of the 2. So that's going to be 2x times 3y, which is going to give me 6xy. And then to remember the signs, okay, that we think same as that one, or same as what we started with, opposite, always positive. So it's soap. Okay, think soap to remember your signs. And then the last thing we have to do is tack that 8x squared back on front, because that was actually part of the problem. You can't just get rid of that. Okay? So when you're factoring, that is finished. Okay, so the 8x squared, we have to recognize that that should come out first. That would be our greatest common factor. And we couldn't have done anything with the x to the 5th or the x squared in that combination. So that x squared would have to come out front before you can apply the rest of the pattern. Okay? Next one, right here. 4x squared minus 81y squared. You look to see if you can take anything out. You can't, because one's an even and one's an odd. And then 2 terms with squares should be difference of squares. So we take the square root of both of those numbers. We're going to have a 2x in front of both of those. and then we'll have a 9y in back of both of those. We just kind of square root the numbers. So same thing in both sets of parentheses. One has a plus, one has a minus. Okay, that is difference of squares. And then all the way at the bottom here. Okay, all the way down here. So solve 4x to the fourth plus x squared minus 5. We cannot take anything out, so we should recognize that that's a fourth and that's a square. So we're just kind of factoring it by, like normal, but we're going to have x squareds in the front of both of our parentheses. Okay, so options are for the 4, we could have a 2 and a 2, or a 4 and a 1. Okay, if I'm looking to get a 1 in the middle, I should kind of recognize that if I just get a 4 and a 5, that I can put those together and get a 1. So we're going to have a 4, we're going to use the 4 and the 1. So 4x squared and x squared, and then we're going to put a 5 there and a 1 there. Then if I check it, that's going to give me a 4x squared, and that would give me a 5x squared. If we're looking to get a 1 here in the center, that means we need a positive 5 and a negative 4. Okay, so we follow that, that's going to be a negative 4 down here. So that means the sign following this arrow will be a negative. Okay, and then we're done with round 1 of factoring. Then you got to ask yourself after that, since we still have squares floating around, can you break any one of these apart? Okay, that's 2 squares being added, can't do anything. That's 2 squares being subtracted, so that's difference of squares. So that one breaks down. So this front one stayed the same. Back one breaks down to x minus 1, x plus 1. And we have a set equal to 0, so we're actually trying to find our solutions. So from this one, we get an x equals 1. From this one, we get an x equals negative 1. Okay, so remember you're just taking those pieces and setting them equal to 0. And this one, I'll do it off to the side so we can see it. 4x squared plus 5 equals 0. So you subtract the 5 from both sides. We get a 4x squared equals a negative 5. Divide by 4 because we have to get that x squared by itself. Okay, so now we have x squared equals negative 5 fourths. That's what we're taking the square root of. Okay, so you're going to have to remember how to simplify something like this. So the negative could come out front as an I, and then you square root the top and you square root the bottom. And we have that plus or minus in front. So that should make it a little bit easier to see what it simplifies down to. So we're going to have x equals plus or minus square root of 5 over 2. And it doesn't really matter if I put the I on the top or the back. I'm just going to put it on the back because it looks a little bit nicer. So I have these answers. So there's 2 of them there. Those 2 answers down here as well. So 4 solutions to a 4th power polynomial. Okay? So that should serve as your review for the quiz. There are problems on the quiz just like that. So now you can please pause the video and have students work through the quiz, and then we'll do a few homework questions after the quiz. Okay, some homework questions that you may have wanted to look through. Some of the factoring problems. So I'll do number 19 for you here quick. For number 19, we have to factor and solve. Okay, it says solve each equation, state the number and type of root. So we have this right here, that polynomial. So x cubed plus 1, so we should recognize there's a 3rd power in there, so that means it's going to be the cubic pattern. So x plus 1, x squared minus 1x plus 1. All right, you don't need that 1x in there, you just have an x, I suppose. But we have to solve it, so set it equal to 0. So this one, we get an x equals negative 1, pretty simple. This one, we got to do the quadratic formula. So negative b plus or minus square root b squared minus 4ac over 2a. And we get that. So this simplifies to I square root 3. So we'll have 1 plus or minus I square root 3 over 2. So that would be your solution for number 19. All right, because 1 minus 4 is the square root of negative 3, which turns into I square root 3. We'll look at number 23 next. All right, 23 has a little bit more factoring involved. So 16x to the 4th minus 625 equals 0. Okay? So how do I know how to factor this thing? It's fourth power. We don't have any patterns for fourth powers. So you look to see if you can take anything out to make that smaller, which you can't. So the only other pattern that you would have would be difference of squares. So we can square root both of those numbers and go from there. All right, so square root of 16 to the 4, and square root of x squared is square root of x to the 4th is x squared. So we have 4x squared in the front of both of those to get to that 16x to the 4th. And then square root of 625 is actually a 25. Okay, same thing in both of those. Have a plus in one and a minus in the other. So this one here, we're going to have to set equal to 0. Actually, we could set both of them equal to 0, but I'm just going to break this second one down a little bit more. So this is the one. This is difference of squares again, so it's just a little bit easier than doing the equation. So 2x minus 5, 2x plus 5. Okay, so from here we can start getting solutions. This is going to be x equals negative 5 halves. This one here is going to be x equals 5 halves. And then the one off to the left here we have to start solving. So minus 25 on both of those. 4x squared equals negative 25. Divide by 4. X squared equals negative 25 over 4. So square root both sides from there. You will get plus or minus 5 halves I. The negative turns into an I, and you square root the top and square root the bottom, just like we did on the quiz review. Okay, so hopefully those made sense. A couple more here. 34 and 38 here. Actually, let's just look at 38. It's a little bit more difficult. Okay, I will do 34. So 34, we have this function. And we have to find all the zeros here. Okay, so you're not given any factors, so that means we have to start trying things. We look at factors of 15 over factors of 1. So 15 numbers that go into 15 would be 1, 3, 5, and 15. And over 1 is not going to change those. So let's start plugging them in until we get a 0. F of 1, f of negative 1. Let's just try those two first. So plugging in a 1, that gives me 1 plus 1 minus 17 plus 15. And that's the 1 right there. So we don't need to care about that negative 1. Let's just use positive 1. So 1 goes in the box. Then we got a 1, a negative 17, and a 15. So my first number drops, multiply it by the number in the box, add, multiply it by the number in the box, add, and multiply it by that number in the box one more time, and add, and we get a 0. Okay? So relisting these as factors. I'm going to use that one. We had an x minus 1 from that, and then x squared plus 2x minus 15 from the other chunk. This one here, we should be able to factor. Okay, so we'll have x minus 1 out in front still, just kind of keeping that along. And then two numbers that multiply to give us 15 and add to give us 2. That's going to be a 3 and a 5. So it'll be x plus 5, x minus 3. So our three solutions are 1, negative 5, and 3. Those are the zeros, or the roots of the equation. Okay? Let's look at 38 quick, and then I'll show you how to set up one of those polynomials with given roots. So 38, you have x to the 5th minus 8x to the 3rd minus 9x equals 0. And this one you can do it with all the rational zeros theorem and stuff like that. That actually takes a little bit more work. So we have an x in each of the terms. So let's take an x out. And then we have x to the 4th minus 8x squared minus 9 equals 0. So So that should kind of look just like some of the things we factored before. Can I factor something when there's an x to the fourth in the first term and an x squared in the second term? Well, probably. Let's try to figure it out. So x stays in front. We got our two parentheses. Trying to factor that. So the x to the fourth would break down to x squared in both of those. Okay, so x squared in the front of both of those. And then two numbers that multiply to give us 9 and add to give us 8. That's 9 and 1. We need a -9, +1. Okay, since we have squares floating around now, you should ask yourself if you can do another pattern. This one right here, difference of squares. So it'll be x minus 3, x plus 3. We don't have anything for sum of squares, so that one just gets rewritten down here. And now we can find all the answers. Okay? Think back to when we factored forever ago. When you have an x in front, that's just going to give you a 0 for an answer. And then this one is going to give us a 3 for an answer. This one here is going to give us a -3 for an answer. And then this one here, you'd set equal to 0 and solve. You get a plus or minus I for an answer. So we have an imaginary number there. So 5 answers for a 5th power polynomial. Last one here. I will look through 42 if we need it. Okay, if you don't, then skip ahead and start the lesson. So 42, we are given -3, 1, and then a -3i. So think back to yesterday. I told you about those complex conjugates at the end of the lesson yesterday. If we have a -3i, those come in pairs, so we also need a +3i. And then you can turn all of those into factors. So these are all our roots here. We just need to turn them all into factors and multiply it out. So this one gives me x plus 3. This one gives me an x minus 1. This one gives me x plus 3i. And then this one gives me x minus 3i. Okay, fix my parenthesis back here. So for the people that worked through this with me yesterday, remember I said that you want to start here. That's the easiest place to start. So if we start foiling there, we're going to have x squared minus 3i plus 3i minus 9i squared. So this right here is the reason that you wanted to start with the imaginary numbers. Okay, and then remember an I squared, -1. So that means this would turn into a plus 9 on the back end. So now we got x plus 3, x minus 1, and x squared plus 9. Okay? We could FOIL this stuff out too right now if we wanted to. So you could FOIL it out 2 at a time, which that's what I'm going to do here. Seems a little bit easier that way. Okay, so when I FOIL this out up here, I'm going to have x squared minus 1x plus 3x, so that's giving me a plus 2x minus 3. So that is what we get when we FOIL those first two out. And we're going to now multiply these. So take the x squared into everything. That's going to give me x to the 4th plus 2x cubed minus 3x squared. And now we take the 9 into everything. So 9x squared. Yep, so I should write that 9 underneath my 3. So 9x squared plus 18x minus 27. Combine like terms, then we're done. So we have x to the 4th plus 2x cubed plus 6x squared plus 18x minus 27. That is our 4th power polynomial. Okay? So hopefully that helps you out for the homework. If you're done, make sure you put your name on top and turn it in now. So please pause the video while students turn in their homework. When they're all done, start it up again. Okay, so we are working through 5152. It should not be terribly difficult. Okay, operations with functions and composition of functions. We've actually done stuff similar to this before, so by the time we're done, you're going to be able to add, subtract, multiply, and divide functions, and then we're also going to be able to compose new functions. Okay, so starting out, you don't have to write anything down. This is just what we're going to kind of see. this right here means add the two functions together. Sorry if it's kind of blurry. There's also in your textbook if you wanted to look at it. So this second one here, f minus g of x, that just means subtract them, okay? And so on. So this means multiply, that means divide. You're going to be given two functions, and you're going to be doing these operations with them, okay? So starting out down here, given the function f of x and g of x, find f plus g of x. So all that means is I add the two functions together. So I'm going to write this one out, so 3x squared plus 7x, and I'm going to add it to this function, which is 2x squared minus x minus 1. And then it's very simple from here. You just combine like terms. Everybody should be good at combining like terms. So I add the x squareds together. That'll give me 5x squared, so those are taken care of. I'm going to add my x's together, so I have a 7x and a negative x. That's going to give me plus 6x, so those are taken care of. And then I have a negative 1 on the back end. So that's it. So f plus g of x is that, 5x squared plus 6x plus 1. Okay, just for the sake of time, this one's fairly simple. I'm not going to have you guys add another one. We are going to look at a subtraction one, though. So we have the same functions from the first one, except now we're subtracting. Okay, this makes a little bit more of a difference with that negative here. So I'm going to show you how you should write it out. So I want to take this function minus this function. Okay, so I got 3x squared plus 7x, and I want to subtract this whole function. So you should put the second one or whatever you're subtracting into parentheses, because what do we need to do now that there's a negative that's crunched in front of the parentheses? That means you're going to have to distribute that negative through there. Okay, or you can just think of subtracting each term. Okay, I think the distributing the negative makes it a little bit easier, a little bit more mindless, and then we can just kind of add pretty much. All right, the parentheses are gone now that I distributed that negative. So now we're just combining like terms again. So 3x squared minus 2x squared is just an x squared. 7x plus x, that's an 8x. And then plus 1. Okay, so we subtracted those two functions. So f minus g of x is that, x squared plus 8x plus 1. Okay, so we're going to skip the addition one here. Don't do this. I do want you to try a subtraction one down here. Okay, so please pause the video and have students work through problem example B. Okay, so shouldn't be too bad. We're doing f minus g of x. That means we're taking this function and we are subtracting this function from it. Okay, you needed to make sure you use parentheses, or you changed all the signs in the second function when you subtracted it. All right, so that's f of x. We are subtracting g of x. So when I'm subtracting that function, I need to distribute my negative through there. Boom, boom, boom. So rewrite that so that way we can see all the sign changes. Oops. So plus 5x plus 2. Now we got a negative 3x squared minus 3x plus 4. Combine like terms now. So 2x minus 3x squared, or 2x squared minus 3x squared, the negative x squared, that's that one and that one. And then 5x minus 3x is a positive 2x. So used up those. And then we have 2 plus 4 is a 6. So plus 6 on the back end. So hopefully we all got that answer. Shouldn't be too bad. So we're just subtracting two functions. Okay, so we covered addition and subtraction. Next we're going to cover some multiplication. So this little dot here, you guys should know that that means multiplication. Another way to write this would be f of x times g of x. Okay, same kind of way, same kind of deal there. So we are going to be multiplying two functions. So if I just write it out as I see it, 3x squared minus 2x plus 1, that's my f of x, times g of x. After I write it out and set it up, it's kind of like a FOIL situation, okay? And I've asked you guys before, but which one do you think we should multiply into the other? it's best to take the little one into the big one. Now there is no one way to do it, but I think it just works a little bit better with organizing. So we're going to take the little one here and multiply it into the big one here. So take the x and run it through. We'll get a 3x cubed minus 2x squared plus an x, and then we take the negative 4 through there. Okay, so that would give me a negative, oops, let's write it down correctly. So I have a negative 12x squared, which goes underneath my other x squared term, minus or plus 8x minus 4. So combine like terms, 3x cubed minus 14x squared plus 9x minus 4. So that's what we get when we multiply the two functions together. Okay, so hopefully that made sense. It's not too bad. We've done plenty of multiplication before. All right, so we're going to use those same exact functions and we're going to divide. Okay, so we're not actually going to take the time to do long division or synthetic division. It's even easier than that. So if we're doing f of x over or divided by g of x, we're just going to write out one over the other. 3x squared minus 2x plus 1 divided by x minus 4. That is it. Okay, that's all you're going to need to do for division. We do need to kind of, since we have division with a variable in the bottom, we have to kind of think of this. Are there any numbers that cannot be in the domain? Any numbers that you cannot plug in for x that would potentially ruin the equation? Okay? And what I mean by ruin the equation, think of if we had something like this, 1 divided by a 0. If you punch that in your calculator says, can't do it, cannot divide by 0. Okay? Is there anything here that would give us a 0 on the bottom? Okay? Should be fairly straightforward. If I plug a 4 in down there, we would get a 0. So my excluded values, I have to say x cannot equal 4. So I have to list that excluded value with my division problem. Another thing you could see is if I had something like this, where you're never probably going to have all 2's like that, but if they're all even numbers or all odd numbers or something like that, then you can divide the 2 out of everything. That would be the only other thing that you could do to simplify. So this would turn into something like this. That would be it. Okay? That's just if you ended up with something that had all even numbers. Okay, let's try a couple on our own. So given that function, f of x and g of x, find f times g of x. And I'll just slide this down. We'll do both of them at once. So please pause the video, have students work through these two examples, and then resume so they can see the solution. So for f times g of x, we have 2x squared plus 3x minus 1 times quantity x plus 2. Multiply those two together. So the x goes through there, and we get 2x cubed plus 3x squared minus an x. Now the 2 goes through there. So that's going to give me a 4x squared plus a 6x minus 2. Combine like terms. 2x cubed plus 7x squared plus the 5x minus 2. That is it. Down below, we're doing division, so you're just going to write f of x over g of x. And really, that is easy enough. The thing that's a little bit more difficult that you have to remember, domain restrictions. What can I not put in the bottom? Okay? My domain restriction here would be x cannot equal a negative 2, because that would give me an undefined problem. So those are your answers for those two problems. That is, we now know how to do addition, subtraction, multiplication, and division. Okay? So if your substitute wants to do this, you can, 4 corners. So if not, you can skip forward through it. 4 corners, remember, this is where I give you a topic and you go to the certain corner of the room. So we'll just kind of look at the first one here. So favorite kind of candy. This is your brain break. So if you want Snickers, you go underneath the TV in the corner. If you like Reese's, you stand by the door. If you like Milky Ways, you stand by the teacher's desk, and if you like peanut butter M&Ms, you're going to stand in the back corner by the word wall. Okay? So move to where you're going. Take about 15 seconds, so get going so you can get to the rest of the lesson. Topic 2. Okay, topic 2, we're looking at your favorite holiday. Okay, so do we like Halloween, Thanksgiving, Christmas, or Easter? So Halloween, you're standing underneath the TV. Thanksgiving, you're going by the front door. Christmas, you're going by the teacher's desk. And Easter, you are going in the back corner by the word wall. So I would probably pick Thanksgiving or Christmas. Christmas because you get cool stuff and everybody likes that. Thanksgiving because you get to eat a ton of food. Next topic, we got 2 more here, okay? So the next one is scary movie. So favorite scary movie or the best one that you like out of this. So It, that came out last year around Halloween, I think. That's with the scary clown. Nightmare on Elm Street, that would be Freddy Krueger. Critters, probably haven't seen it. It's kind of a funny movie if you look it up. Friday the 13th, I think that's Jason, okay? So move to where you need to go. It would be underneath the TV. Nightmare on Elm Street would be by the front desk, or the front door, sorry. Critters is by the desk, and Friday the 13th is by the word wall. And last one here. Favorite meal here at Seward High. Do you like Chili's, tacos, spaghetti, or stromboli? Okay, so move to your area, and then after everybody is kind of dispersed, go back to your seats, please. That would be your brain break. So the next thing we're looking at here will be the last thing for the lesson. We're looking at composition of functions. Okay, so composition of functions. So think of a function, this is the f of x stuff. Composition of function is plugging the value from one function into another function. Okay, it can also be plugging one function into another function to create something new. Okay, so this right here is really truly what we call composition function because you're creating a new function. All right, so we're going to be looking at something like this. We are given the function f of x and g of x and h of x. Okay, we could use one of those, 2 of those, or all 3 of those for function composition. Okay, so really what we're looking at for a here, we're looking at is, so the way you would read it would be f of g of 4. Okay, so if we kind of think of it just like this, so forget about the f for now. G of 4, you guys should totally be able to do that. Okay, so g of 4, that means I'm just plugging in a 4 into my g function, so it'd be 3 times 4, which is 12. Okay, but we have f of g of 4, so this is now going to be in the place of that g of 4 there. So really we're looking for f of 12 because we did the g of 4 already. Okay, so f of 12, so my f function is the 2x minus 1. It would be 2 times 12 minus 1. So that would be 24 minus 1, which is 23. Okay, so f of g of 4 is a 23. Okay, so we should be able to do the next one. I'll kind of work through it slowly, try to kind of keep ahead of me, see if you can figure it out. So we're doing f of 6 first, so we look inside first, and then you work out. So f of 6, that means we're plugging 6 into the f function, so it'd be like this. That's going to give me a 13. So 12 plus 1 is 13. So then we're going to do g of 13. Okay, so we find our g function. It's just 3x up there, so it'd be 3 times 13. So that's 13, 26, 39. So f, or g of f of 6 is 39. Okay, a couple more down below here. So this is actually function composition here. We have g and a little dot there, h, and then x. So this right here, that little dot, the open circle there, that's function composition. So I'm composing. I'm g, I have function g compose h, all right? So the same way to write that is this, g of h of x. All right, and we always work inside out, just like I said on the last one. So we're going to take the h of x function there, and we're going to plug that into my g function, okay? So h of x is x squared plus 1, and g of x is 3x. So we're going to take this stuff here and plug it in for the x. So it would look like this. We'd have 3 parentheses x squared plus 1. So we're plugging the h function into the g function. All right, and then we just distribute and simplify it as much as we can. So 3x squared plus 3. That right there is g of h of x. So I composed the new function, 3x squared plus 3. For the next one over here, for d, we're going to do the same thing. We're taking the f function and we're plugging it into the h function. Okay? F is 2x minus 1, and h is x squared plus 1. So we're taking f, that 2x squared plus 1, or 2x squared minus 1, 2x minus 1, excuse me, plugging it in for the x of that function. So that means I'm putting 2x minus 1 in parentheses, and I'm writing it squared because that would be plugging in for that x there. And that's what it would look like after I plug it in. Okay? So again, I took the 2x minus 1, and I'm plugging it into the x of the h functions, because we're doing h of f of x. Okay? So this right here is not just going to be 4x plus 1. It's a FOIL. Okay? Don't make that mistake. We got to FOIL that out. So if you remember the pattern, it would turn out to be this after I FOIL it. Or you can just write it out twice and FOIL it out. Okay? So 4x squared minus 4x plus 1. And then we just have to simplify it from there. So 4x squared minus 4x plus 2. That right there is h of f of x. Okay, I composed the new function. It's 4x squared minus 4x plus 2. Okay, let's try a couple more of these, see if we can figure them out. All right, don't worry about this one down here. Forget about it. It's a hot problem. That means higher order thinking, so that means it's a little bit harder. So I want you guys to try to do the 3 problems that I have here. Try to work through A, B, and C. So please pause the video and give the students a little bit of time to work through these 3, and then press play again and it'll go through the solution. Okay, so for A, we're doing g of 18 first. All right, so let's plug an 18 in there. So 18 minus 9 is a 9 inside there. Square root of 9 is a 3. So we're going to do f of 3. And my f of x function is the 9x minus 9, negative 9x, excuse me. Plugging the 3 in there, minus 9, so this will give me a negative 27. Minus 9 is a negative 36, so this one equals a negative 36. For B, remember I said that that little operator there, that means function composition, so that's the same as doing this. F of g of x, where I take the g function and plug it into f. Okay, so g is the square root one, and we're plugging that into f. So it looks like this, negative 9 square root x minus 9 with a minus 9 back there. And we haven't worked a whole lot with square roots yet, but you can't do anything from there. Okay, you cannot distribute into a square root, you would just leave that out front, and since we have that subtraction sign inside there, you can't do anything to simplify the square root. So that right there is just your answer. It looks kind of goofy, but that would be our answer. Okay, because we took the g function and plugged it into the f function. And then the last one down below, C, we're doing g of f of 2. Okay, so remember that little dot operator there? That's just a different way to write it. So this would just be written as g of f of 2. Like that. So we do f of 2 first, and then we plug that into g. All right, f of 2 would look like this. So that would give me a negative 18 minus 9, so a negative 27. So that's what we're plugging into the g function here now. Okay, so we would have square root negative 27 minus 9. All right, so that gives me negative 36 underneath there, square root of negative 36. And we can simplify that. We know the square root of 36 is 6, and a negative underneath there gives me an I. So this would give me a 6I if I were to simplify that down. Okay? So hopefully the function composition stuff makes sense. If you need some extra help, you can go to YouTube or you can go to our textbook resources. If you just type in function composition in YouTube, you'll get a ton of videos. Okay? Here's your homework for the assigned sections here, so 5, 1, 5, 2. Try to work through these. Let me know if you got any questions. All right? Good luck.